So now we are ready to turn to one of the four main propositions that come from a neoclassical model of trade. Okay, and we are moving to factor price equalization proposition. So, as the name suggests, this proposition should tell us that the trade will equalize prices of the factors of production in two countries. But let's read the proposition first, and then we will explain what is in this proposition. Okay, in a neoclassical framework with two final goods and two factors of production, there is one-to-one correspondence between the prices of the final goods and the prices of the factors of production, provided both goods are produced. Okay, so this proposition should seem at least weird to you. Why? Well, in a neoclassical framework with final goods and two factors of production, there is one-to-one correspondence between prices of final goods and prices of factors of production, provided both goods are produced. This is the assumption that we will maintain for the rest of our considerations of neoclassical model of trade. But look, what we see over here is a description of an autarky. We are talking about one country in which we have two final goods, two factors of production. And what this proposition tells us? This proposition is telling us that there is correspondence between prices of final goods and prices of factors of production. What this means for us is that once we know prices of factors of production, so we know the wage and we know the rent, we should be able to find prices of manufacturers, price of manufacturers, and price of food. But it also implies that if we know the prices of manufacturers and prices of food, we should be able to find wages and rents. Okay, but still, even if it turns out that this is true, and we will be proving that this is true very soon, what does this imply? What has to do with international trade? Well, at this moment, you might just say nothing. But this is why we need to turn to corollary. In other words, we need to look at what this price equalization proposition implies once we turn from autarky to a situation when international trade is present. Okay, again, let me just read it first, then we will discuss all the details. So, in a neoclassical framework with two countries, two final goods, and two factors of production, well, now we talk about international trade. We've got two countries. So, international trade of the final goods, which equalizes the prices of these goods in the two nations, also leads to an equalization of the rewards of the factors of production in the two nations, provided both final goods are produced in both nations and the state of technology in both nations is the same. Okay, now it starts to make sense. Look, we can very easily imagine that if we have two separate countries that do not trade with each other at all, the prices of different goods will actually differ between these two countries. But once there is international trade, due to arbitrage, because look, if we have international trade and price of the one good is higher than the other, in one country than in the other, the rational thing to do is buy where it's cheap, sell where it's more expensive. And of course, this will lead to equalization of the prices for as long until there are still some arbitrage opportunities. Once we've eliminated these arbitrage opportunities, prices in both countries should be the same. Of course, no transportation swing, no transportation cost, no tariffs, and so on. So, we see that international trade will provide equalization of prices. But now, thanks to this proposition, we see that those prices are determining wages and rents in both countries. So, in turn, as those prices are getting equalized, the same should happen to wage and rent. Of course, provided both goods are produced and the state of technology in two countries is the same. Okay, so this is the first of the main predictions of neoclassical model of trade. But for now, we just said what it says. Now let's try to actually establish those links and how they work. Okay, so in order to achieve that, we saw we can take two approaches. From prices of factors of production to goods prices, and this is from factor prices to goods prices. And we can do it in the opposite direction. So if we have prices of goods, we can determine prices of the factors of production. We will take two separate approaches. Well, not separate. We will start with this one because it's easier. We've already laid a lot of groundwork. To make the connection. And once we're done with this, we'll see if it will also work in the opposite direction. If it works in the opposite direction. So look, basically, what do we have over here? If we have wage and rent, this should be enough for us to establish this cost line. Now, once we have ISO cost line, it's not a problem for us to find a unit value ISO points. And from those, finally, we will arrive at prices of manufacturers and food. Okay, but in order to derive directly this proposition from the model, we need to remind a couple of things. We've actually calculated that an optimal level of labor hired by the companies is given by alpha m over 1 minus alpha m w over r to the power negative alpha m. And of course, remember, we can do exactly the same thing for food. We just need to replace the substrates. And now, by the same token, we've calculated that capital used in the production of manufacturers is given by alpha m over 1 minus alpha m w over r to the power 1 minus alpha m. Okay, this is something that we've already found. Now we're going to use it to find unit cost of Okay, we know that while producing 1 unit, and this is what we've been dealing with all along, we've got W ln plus R times K. So labor cost, capital cost. Okay, so now we can take those two expressions and put them instead of ln and km. So we've got that this is W times alpha m over 1 minus alpha m, W over R minus alpha m plus R alpha m over 1 minus alpha m, W over R 1 minus alpha m. Okay, and look, right away we can see that W's are over here, repeating, R's over here. So maybe first thing we should do is to take those out of the parentheses. Okay, and let's see what we're gonna have. Okay, so look, I have W here, and here I have W to the power negative alpha m. So I can just collect those terms together. Then I have here R to the power negative 1 taken to the power negative alpha m. So in this case I multiply the powers and I get that this is R to the power alpha m. Okay, and then let's leave the rest the way it is, right? Okay. Then I can do the same thing here. Look, right away I can take W to the power 1 minus alpha m out. And now, look, here is R to the power of 1. Here is R to the power negative 1. So, after multiplication over here, we would have R to the power negative 1 plus alpha m. Now, multiplied by R to the power of 1, I'm ending up with R to the power alpha m. Okay, and then let's just rewrite everything left I got there. Of course, without this. Minus 1 minus alpha m. Okay, and now I clearly see that those two expressions are the same. So let's take them out of the parentheses. Okay, let me change the order because this is the order that, let's just say, we are going to prefer. Okay, and now what is happening over here? Now, let me rewrite all those expressions separately. So I will have here alpha m to the power negative alpha m. And look, out of this, I have here this expression to the power negative 1. So I will have times 1 minus alpha m to the power alpha m. And over here, plus alpha m to the power 1 minus alpha m times 1 minus alpha m to the power negative 1 minus alpha m. Okay, so let's carry on. Let me just erase some part of it. Okay, what else? So, what I'm gonna do is I'm gonna take alpha m to the power negative alpha m out of the brackets, right? So we got that this is R alpha m times W to the power 1 minus alpha m to the power negative alpha m. Okay, and let's see what we've got left in the brackets. So we've got 1 minus alpha m to the power alpha m, because we've taken this thing out, and over here we've just left with alpha m to the power of 1, right? Now, and this expression simply stays the same. Alpha m to the power negative 1 minus alpha m. Okay, did we get everything? So, finally, we should also get rid out of some expression with 1 minus alpha m. Let's get rid of this one, because this one is definitely the most problematic for us at this moment. Okay, so we got r alpha m times w 1 minus alpha m times alpha m to the power negative alpha m times 1 minus alpha m to the power minus 1 minus alpha m. And what do we have left in the parentheses? Well, this part is gone, so somewhere at the end we have just a alpha m, right? And now look, if I'm going to take this one out, this part out of this, what do I have to do? I need to add this expression here. But look, if I'm going to add this, it's 1 minus alpha m, it just turns into the power of 1. So what I've got left here is 1 minus alpha m plus alpha m. And we clearly see that those cancel each other out. Here we have 1. So over here, we finally arrived at the final solution. Okay, and the final solution here is Cm. So the unit cost is equal to gamma m r alpha m w 1 minus alpha m, where gamma m is equal to this expression. We don't need it. We actually wanted to have a connection between factors of production, and those are technical parameters that are not of interest to us. Okay, so we've established unit cost. But what does it give us with the relationship, in the case of the relationship between prices of final goods and prices of factors of production? Now we can take advantage of another assumption that we've taken before. The assumption that we've got perfect competition, and we are considering long-run equilibrium. What is happening in the long-run equilibrium? Well, in the long-run equilibrium, we've got the price of a good is equal to unit cost, because all the economic profits are gone. And this is actually what we needed, because now I can write that the price of manufacturers in our economy is given by gamma m times rent to the power alpha m times wage to the power minus alpha m. And consequently, I've also derived price of food, because it will be equal to gamma f times r alpha f w 1 minus alpha f. Okay, so we have now shown that once we have factor prices of two goods, we already can find prices variables. In the second step, we will go in the opposite direction. So we will go from prices of goods to factor prices, and this is the topic we're going to take up in the next video. Thank you for your attention.